Today, all apps are reliant on a cloud connection to work. That being said, there are so many ways that a cloud connection slows or breaks. There's loss of cell reception, the app crashes, the device is low on battery, there are dead zones in the field, or sometimes even the cloud service you're using may slow or have an outage completely. With unmitigated weaknesses like these, traditional apps can lose connection while in the middle of uploading crucial data, massively complicating operations. We saw this problem and decided to build a software developer toolkit that, when embedded into your app, allows your devices to sync data with and even without the internet. Furthermore, apps embedded with Ditto can show and edit data even when offline. For example, these two devices, despite being disconnected and offline, can edit data simultaneously. When the devices reconnect, syncing is immediate and automatic. Any merge conflicts are automatically resolved using CRDTs over Ditto's peer-to-peer network, ensuring that all data is preserved. Ditto is a peer-to-peer system with two types of peers, big and small. What we call the small peer is what is embedded into every single device. It can utilize whatever network transports are built into that device. For example, a phone can use Bluetooth, local area network, and peer-to-peer Wi-Fi, and of course cellular networks when they're available. Its replication is selfish, which means that it only downloads the data that it needs from other peers. Because we're talking about small devices that have a limited capacity. In an iPhone, there's only 128 gigabytes of space, so you need to control what you're downloading into it. The big peer is a cloud or on-premise sync system that can handle large amounts of data. It is greedy, which means that it replicates as much as it can from all small peers while they're online, aggressively caching that data in the cloud with a very advanced internal partitioning system. So what does this look like in practice? When you add data on one end of the peer-to-peer system, it synchronizes through all the peers, even if they aren't directly connected to the internet. We call this multi-hopping. Data can daisy chain its way between devices in the connected mesh. Not every device needs to be directly connected to every other device, or even to the internet, to get the latest updates of data. Now let me show you a demo. Here is a simple inventory tracking application syncing cross-platform with 2 iPhones, 2 Android phones, and an iPad. This example is a great showcase of our lightning-fast data sync. This is the Ditto Presence Viewer. It showcases all currently utilized transports within a specific mesh, and updates in real time as conditions change. This can be seen when one device is put into airplane mode, disconnecting the device entirely from its peers. When disconnected, edits can still be made to the embedded database. When the device is reconnected, offline data and conflicts are resolved instantly. Ditto automatically handles the complexity of utilizing multiple transports so that you don't have to worry. And it's really easy. Download this demo app and more from our website, or sign up through our portal to start syncing today.